let's read number this one. It says the formula, a lot of times in these story problems, they'll give you this weird formula that you've never seen before. That's besides the point. So it says the formula 1 over f equals 1 over p plus 1 over q is used in telescope and camera construction, where f is the focal length. So basically you are going to need to pay attention to what does f stand for. So everybody help me remember. F is focal length of the lens. In general, the larger the f, the more power the telescope has. The variable p is the distance from the object we see to the lens. So I've even drawn a picture for you, notice. And then it says the variable q is the distance from the lens to the point of focus, such as the film of your eye. The see figure below. In the first part of the story problem, it says solve for q. So what we're going to do is we're going to go back to our equation and we're going to just get q by itself. So we have 1 over f equals 1 over p plus 1 over q. So piece by piece, we're trying to get q by itself. So wouldn't it make sense to subtract 1 over p over? We're trying to get it piece by piece, q by itself. Does everyone see? So then we would have 1 over f minus 1 over p equals 1 over q. Now, just a reminder here. From here, there's a couple ways to do this problem. This is how I would do it. I want to bring q on top, but I can't flip q unless this side only has one fraction as well. So let's get this and this together. So we know how to add fractions. We need a common denominator. So we would times by p over p, f over f. So now on this side I have p minus f over pf. And that's equal to 1 over q. And now because I have a fraction on the left, one fraction on the left, and one fraction on the right, and I want q to be on top, we can actually just flip both. So this side now is pf divided by p minus f, and then we have equals q over 1. So do you guys see how now we've just solved for q using algebra? Okay, now from there it says, okay, suppose the camera has a focal length of 100. So remember, f stands for focal length. And it says, and the camera is focusing on an object 500 meters away. It says, what is q? The distance from the lens to the point of focus. So now from here, it's just a plug and chug problem. So f is 100, p is 500. So we'd say 500 times 100 divided by 500 minus 100. And that's equal to our q. So then we'll type it into our calculator. If you all have a calculator out here, we're going to go much quicker because then I don't have to type it in because you've already typed it in for me. I get 125. 125 equals q. So they must be a distance of 125 feet. Okay, pretty easy, right? All right, let's do another one. Okay, so here's just a reminder. You don't need to write anything down, just pay attention. What we have to remember is that if we have similar figures, we can set up ratios of corresponding sides. Now, what I mean by that is similar figures are the same shape, just different sizes. They're just similar. Now, what I mean by is we can set up a ratio of corresponding sides is ratio means division, corresponding sides means this. A corresponds to side D. Corresponding sides sit in the same position. You guys see how A and B correspond. What else corresponds? C to F, B to E. Those are corresponding sides. So you can actually set up division of corresponding sides. So we could say A over D, the ratio of corresponding sides will equal B over E. That would be a true statement here. Do you guys see how I just did that? Now, here's what you do have to stay consistent with. I chose to put the bigs on top, so I went A to D equals B to E. Make sure you stay consistent. So you couldn't go like this. A to D equals E to B. Does that make sense? You got to stay consistent. Okay, so tell me what's the true statement here. One true statement. There's a million true statements. What's one? A over F would equal? Sure, B over D. That is true. Does everybody see how they got that? They just set up a ratio of corresponding sides. Okay, great. So we're going to actually use that idea for this problem. It says, suppose you are standing next to a tall building and wish to know the building's height. So let's start drawing this as we read. Here's our building. We wish to know the building's height. A light post that is 20 feet tall, so here's my light post, not drawn to scale, is 20 feet tall. And it casts a shadow that is 12 feet long. Great. It says the shadow from the building is 660. Now it says, how tall is the building? Do you guys see how it says ratio of corresponding sides? What I would always do is set up x on top. So we're going to go x corresponds to 20. Doesn't that sit in the same position, everyone? X over 20 would equal 660 over 12. And now our algebra tells us to solve for x by timesing by 20. So then you would do 660 times by 20 divided by 12. And we get x is equal to 1,100 feet tall, which makes sense, right? A building can definitely be that many feet tall. Pretty easy, right? Ratio of corresponding sides. So look at this next problem. It is the exact same idea here. Now it's not a shape, but it's a ratio of corresponding things. So let's read it. According to the National Vital Statistics report dated December 17th, 2003, the birth rate for unmarried women 15 to 44 years of age was 44 live births. So 44 live births, I'll just put B for births, per 1,000 population. It says in the United States in 2002, there were 1,366,000 births. So I'm going to line that up with births. 1,366,000 births. And then it says, what is the population? So we don't know X population, right? It says, what would the population be? Do you guys see how it's corresponding? Now, I know people these days could get offended over this story problem. Like, I could see people being like, who cares if they're unmarried? I don't care. You can give birth to children all day long. So I didn't make this problem up. I just got it out of a book. So don't write me up. Okay. I don't care if you are unmarried or not. Here we go. So let's set up some let's set up a true statement here. Wouldn't you want to put X on top to make your life easier? So what would we put? X over 1,000, right, everybody? We're going to do corresponding sides equals 1,366,000 over 44. So then from there you would times up by 1,000. So then you'll do that in your calculator. Oh, I typed it in wrong. That's why you guys should be typing it in, because you're probably quicker than me. I get X is equal to 31045,454, and then it's 0.55. But since it's births or population, people, I'm not going to do the decimal. 55% of a person, nah. So then we'll just put in our commas. Does that answer make sense? Yeah, right? Isn't it much bigger? Isn't the population much bigger than the amount of births going on? Yes, let's hope so. Okay, awesome. All right. See, this one you're going to want to pay attention to. This is one I would put in my notes. I wouldn't write down the whole story problem, but this is what I would write down. 1 over t. So guys, this is always how we're, and I'm telling you, like there definitely will be like one like this on the test, and it's going to be one of the easiest ones on the test. But you do have to know what you're doing. So this is always how we set up these two types of jobs. This one job given two people doing it together type of situations. So what will happen is they'll give you, this person does a job by themselves, this person does that same job by themselves. How much time if they work together? We're always going to set it up as follows. Okay, let's read this. It says, it is Saturday and Kevin needs to cut and edge the grass. At 9 a.m., Mike asked Kevin to go golfing at 11 a.m. So how many hours later are they going to go golfing? In 2 hours, they want to go golfing. Now it says, typically it takes Kevin 3 hours to cut the grass. So could he do it by himself and make it in time? No. Then it says it takes Mike, how long? 4 hours. So Mike's even slower. So it takes Mike 4 hours. So they definitely by themselves could not make it to golfing. It says though, if they work together, could they get the job done in time? So let's see here. Everybody, this is how we're going to think about it. So let's put this in terms of 1 hour here. So if they can get the full thing done in 3 hours, in 1 hour, how much of the job have they got done? 1/3. You guys see how it's 1 over t? 1/3 of the time in an hour. So in 1 hour, they have 1/3 of the job done. All right, right here, in 1 hour, How much does Mike have? A fourth of the job done. So now let's go ahead and put them together. So if we have a third of the job in an hour plus a fourth of the job in the hour, we want to know what will that equal. So that will equal 1 out of, we don't know how much time. You guys see how we set that up? We don't know how much time it's going to take when they do it together, but you get why I'm adding them, right? Okay, so let's solve for t now. So now it's just solving for t. So you'd say, I need a common denominator. So wouldn't it be 12t? So I'm going to times by 4t times by 4t. 3t, 3t. This one needs a 12 and a 12. We're solving, so can't I ignore the denominator now? All right, so then look at your true statement. 4t times 1, which is 4t, plus 3t times 1, which is 3t. We want to know when does that equal 12. So that's 7t equals 12. Solve for t. Divide by 7, divide by 7. So the time in 1 hour. So why do we always put 1 on top? Because we're doing 1 hour. Do you guys see why I'm doing 1 on top? Okay, so how much time? 12 divided by 7 is 1.7. They got done in 1.7 hours. So can they make it to golfing? Yeah. Now, if you were extra special, you could convert this 0.7 to minutes. So you would take 60 minutes and times by 0.7, and that comes out to be 42. So it took them 1 hour and 42 minutes, but you could, I don't care if you leave your answer. I'll give you full points here or here. So if you don't want to do extra work, just leave it. Hopefully that makes sense. So we're always going to set these ones up like that, okay? So just remember that. So let's do one more, let's practice one more like that to make sure that we're good. Let's read it. Juan and Maria have a pool in the backyard. If they use their hose alone, it takes them 30 hours to fill the pool. They have a friend who has the same pool, but their hose can fill the pool in 24 hours, so their friend have a better hose. If they work together, how long will it take for Juan and Maria to go swimming? So I just told you you'd set it up the same way. What would be our true statement? 1 over 30 plus 1 over 24 equals 1 over t. Do you guys see how we just set it up the exact same way we just did that? So then from there you'd get a common denominator. You'd say, okay, we times by 20. But it could be smaller. I'm just going to go ahead and just go for it. I have a calculator. So I'm going to times by 30t, and I'm going to times by 30 times 24. That's 720. So then from there, don't we have 54? We can ignore the denominator. So 54 t's equals 720, right? So then 720 divided by 54. 13.3 hours equals t. It took them 13.3 hours to fill the pool. Pretty easy, right? That will be one of the easiest ones on the test. It would be so sad to miss it just because you didn't memorize what you're supposed to do with that type. Yeah. So, yeah, because we're doing it, okay, so in 1 hour, this will get a third of the job done, right? And then in 1 hour, we'll have 1/24 of the job done. So when we add them together, that will give us the total time it takes per hour, like in hours, in 1 hour. So that's why it's 13.3 hours. I don't know how to answer the question very good. I'll be thinking of how I can answer that better. Because you're asking, how do we know that that's the total time? Oh, I can see what you're saying. Like you're thinking, why isn't this per 1 hour? Like 13.3 of the job or something. Well, do you see how now when we solve, it's the t's on top? Not 1 out of t. Does that make sense? So the algebra is now just t in hours. Isn't t hours? Does that make kind of sense? Okay, I'll be thinking of how I can answer that better. Sorry. Hey, let's read this one just because most of the time you're adding, but there are times when you're doing that same type of problem with subtract. So let's read this. Now, because we're adding because they were both going in at the same time. So we're adding up how much they're getting done. Now read this one. Suppose a kitchen sink can be filled in 5 minutes. So here's our sink. It can be filled up in 5 minutes. So filled up to the top equals 5 minutes. It says, if the sink is full, it takes 8 minutes to drain out onto the floor. Sure. That equals 8 minutes. It says, if the drain is left partially open, if the water is going in and out, how long will it take to fill the sink? So first of all, this one's going to be a subtraction problem. Don't we have water going in? And we're going to subtract out the water going out. Does that make sense? So in 1 minute, we're now doing minutes. In 1 minute, we'll have a fifth of the sink filled up, correct? Now we got to subtract off. In 1 minute, we're going to be draining an eighth of the sink. Eight of the sink, right, everyone? An eighth of the sink. And that's equal to 1 over t, where t is in minutes in this one. So now from there, we'll get a common denominator. So you guys see why it's subtraction, because it's going out versus both going in. So now from there, we'll times by ht times by 5t times by 40. So then from there, we have 8 minus 5, which is 3. 3t equals 40, because I'm just ignoring my denominator now. So then 40 divided by 3, 13.3. So the time is 13.3 minutes. Which makes sense, you guys. It's going to take quite a while for us to fill this up, right? If water's draining out and water's coming in, right? Does that kind of make sense to everyone? Okay, awesome. We're actually almost done. Our last couple story problems here. So we've already learned this stuff earlier in the year. We just have to review distance, rate, and time problems. So let's review them. You guys have done really pretty good with distance, rate, and time problems before. So let's do this one. It says, a plane flies 990 miles west into the wind and makes the return trip following the same flight plan. The effect of the wind on the plane is 20 miles an hour. The round trip takes 10 hours. It says, what is the speed of the plane in still air? So everybody, if you'll notice in this wording of the story problem, we can see there's going to be distance equals rate times time. Remember, this is something you need to go to the test memorizing. Now, if you have a distance, rate, and time problem, usually you have two true statements. So let's set up a true statement. So the plane flies on the way there 990 miles west. So wouldn't our distance be 990? That's equal to our rate. Now, don't we not know the rate of the plane? So let's call that x. But we do know that the effect of the wind on the plane is 20 miles an hour. Now, right here it says it's on the way there, it's going into the wind. So doesn't that mean the wind's pushing against us? So our rate is x, the rate of the plane. Here's our plane flying, you guys. It's going some rate, but then the wind is pushing against us at 20 miles an hour. Does that make sense, everyone? So x minus 20. Now, we don't know anything about the time. So t, let's call it time 1. The time of the trip, the first trip. Time 1, sure? Okay, let's set up another distance, rate, and time problem. What's the distance? Now we're coming back. Isn't the distance 990 again? But now the plane is flying with the wind. So now we have a 990 equals our rate is x plus 20, and this is the time on the way back. Now it says, what is x? So first of all, you have to set up a true statement to be able to solve for x. Now it did tell us the round trip, which is total time. So we know the time of the first trip plus the time of the second trip equaled 10 total hours. So we can now use this top equation to solve for T1, because we have to set up a true statement involving time, because that's what we were given. It equals 10. So solve for T1. What do we divide by x minus 20? So time on the first trip is 990 over x minus 20. Plus the time for the second trip, solve for time 2, so divide by x plus 20. The time of the second trip is 990 over t plus 20. And we know that equals 10. So now we just have a rational equation to solve. And the thing is, with these type of plane problems, which there will be one like literally almost just like this on the test, they use big numbers because they want to make it realistic. You'll just need your calculator. So from here, I would draw in my 1 over my 10 and say I need a common denominator. I used x and t. I should be using the same variable. We'll call that x and x. Okay, there we go. Okay, let's get a common denominator so we can solve. So we'd multiply by x plus 20, x plus 20, x minus 20. And then what does the 10 need? X plus 20 and x minus 20. Then from there, you can Continue solving just with the top. So now I'm going to ignore this bottom. Here we go. So we have x times 990, that's 990x. 9 times 20, or 990 times 20. So plus 19,800. Then we have a plus sign. 990x again. Minus 19,800. That's equal to. Now look at me distributing this bad boy. What I would do is, I've got to write it down here. Put my 10, throw in some big parentheses. Let's distribute. X times x is x squared, right? Minus 20x plus 28x would be gone. Conjugates have middle terms cancel out. And then we have minus 400. So now let's set up our true statement. Let's combine like terms on this side. So that would be 990 plus 990. So that's 1,980x. And then these cancel out. That's equal to, distribute your 10 in, 10x squared minus 4,000. Now look at your true statement. Isn't it a quadratic? How do you solve a quadratic? Get it equal to 0. So I'm going to subtract this over. So I have 0 equals 10x squared minus 1980x minus 4,000. Now what I'm going to do from there is factor out a 10, then divide everything by 10, because then my numbers are much smaller. So then we have x squared minus 198x minus 400. And then you'd say, okay, now I can solve by factoring. It's quick factoring. Well, multiplies to be negative 400. It's actually easier than it looks, so don't give up just because it's big numbers. And adds up to be negative 198. So then I literally take my calculator and do 400 divided by 2. And then that's 2 times 200. Isn't that the one? Yep, so it'd be negative 200. So this quick factors to be x plus 2 and x minus 200. And then we still have our 10 in front. Now solve. 10 does not affect your solutions. X equals negative 2 and x equals 200. X stood for the speed of our plane. So wouldn't it make sense to throw out the negative speed of the plane? So the answer is 200 miles per hour. We're going to do one final one where we set up just like that. We don't have to go through the whole thing, but I want to make sure we can set it up right. Okay, last example. Yeah, this is my last example. Okay, a canoe travels on a river whose current is running at 2 miles an hour. After traveling 12 miles upstream, the canoe turns around and makes the 12 miles on trip back downstream. The trip up and back takes a total of 8 hours. What is the speed of the canoe? So you'd say this is a distance equals rate times time. Distance equals rate times time. What's my distance? 12. My rate is x plus 2, right? Wait, is it going upstream? So isn't it usually getting pushed against then? Yeah. So x minus 2 times the time of the first trip, right? Distance is 12. Our rate on the way back is x plus 2, and that's time 2. So then time 1 plus time 2 equals total time. So then my true statement would be solve for time 1. 12 over x minus 2 plus time 2. 12 over x plus 2. That should equal 8 over 1. And then get a common denominator solve. It's a quadratic. So you can see how they really all just set up the exact same. That's how they're going to set up on the test too. So don't just say to yourself, it's okay, I'm just not going to worry about the story problems. I just always miss those, because these ones you shouldn't probably miss. Let's make this the one time that some of us don't miss the story problems, because they all are going to set up very much like that. All right, the rest of the examples are no longer needed to be learned. So hallelujah for us. So don't follow these instructions. I've had to take off some problems since UVU is no longer requiring us to learn them. So follow the paper. I've specifically given you the problems that you should do. So yes. All right, the rest of the time is yours. You have about 19 minutes.